Hello guys, welcome to Ramta Solutions. Welcome to another lesson on grade 10 graphs / grade 10 functions. Today we will be looking at your hyperbola. Which have the equation y equals a over x plus q. Okay, so again, this is still the output, this is still the input, and okay, let me not talk about this one as yet. This basically tells us which quadrant will the arms of the hyperbola lie. So if hyperbola is positive, A is positive, the hyperbola will be between the first and the third quadrant. And if it is negative, it'll be between the second and the fourth quadrant. It'll be like this. Okay, now again we also have to talk about this guy. He represents vertical shift or vertical translation. If this guy, just like we described him in parabolas, if he is positive, he shifts up. If he is negative, he shifts down. Again, he represents horizontal asymptote. So this is a region where your graph does not exist. Okay, this is a region where your graph does not exist. So I will always write these dashes. So the equation for the horizontal asymptote, you will say y equals q. Okay, you will always say y equals q. There's something that I wanted to add on the denominator here, that this is the part where that says you have an asymptote. That asymptote here is the what we call the vertical asymptote. Okay, vertical asymptote. This is where the graph does not exist as well, but this value cuts the x-axis. Now for grade 10, this value is at x equals 0. Grade 10 only. Okay, for grade 10 only. In grade 11, your graph will be shifting horizontally. Right now, when you're in grade 11, your graph will be grade 11 and 12. In fact, your graph will be shifting horizontally. But now that you are in grade 10, your graph doesn't shift horizontally. What does it do? It only shifts vertically. Okay, it only shifts vertically. Okay, all right, now let's get into it. So now I have spoken about the effect of A. When A is positive, the graph is between the first and the third quadrant. When A is negative, the graph is between the second and the fourth quadrant, right? So having covered that, we are sorted. So let me now look briefly, and maybe not briefly, but let's now focus on asymptotes amongst other things. So we will now focus on asymptotes. Okay, we will now focus on asymptotes. Okay, so we have first, we have the horizontal asymptote. So horizontal asymptote. So horizontal asymptote, I like writing these lines. Basically, this is where this is an x value, all right? this is an X value. I mean, it's a Y value, not X value. It's a Y value, right? It's a Y value where the graph does not exist. Okay, let me just use the word invalid. Okay, where the graph does not exist. Okay, so for a general, or rather for a grade 10 graph that says y equals to a over x plus q, your horizontal asymptote will be this y value. If you can substitute this y value, your function will not be possible to work with, right? Your function will not be possible to work with. In this case, let's see. What I'm trying to say is that you will get something that is you cannot even place on your calculator, because you'll be forced to maybe divide by 0. For example, let me try, I don't know, let's say what happens when y, let's try when y equals q. Let's see if we can solve for x. Let's see. Q equals a over x plus q. What is this? This is 0. Okay, q minus q equals a over x. Now what is this? This is 0 equals a over x. And when I look at it, this is 0 equals a. Do you see now? 0 equals a. I mean, the reason why I said 0 equals a is because I tried to say, can you see that? Now, what happens? You said y equals to q, but where is the value of x? You don't have the value of x. Now, this is where you must say y must not be, y, yes, when y equals to q, you will not have, when y equals to q, you will not have a corresponding x value. So this does not, your graph, what it means, your graph does not exist at y equals to q. As you were able to see, basically, we should, when we talk domain and range, you will see this thing that basically y should not be equal to q. Okay, when y is equal to q, you will realize that your function does not exist. Now you will understand when we talk of the domain. Okay, but right now your horizontal asymptote says when y is equal to q, your graph does not exist. Okay, cool. Now this is your horizontal asymptote. Okay, so this is your expression. Know this, it's your horizontal asymptote. Now I'm going to look at vertical asymptote. Now vertical asymptote, maybe I should have done this. Vertical asymptote, now with the vertical asymptote, we basically looking at the x values. Now I also like writing this one vertical, right? We're looking at the x values, right? So we're looking at the x values, of course, where the graph does not exist. Okay, maybe let me not say x values, but x value where the graph does not exist. Right, let me say x value where the graph does not exist. Okay, where graph does not exist. Now check this out. We have y equals a over x plus q. I want you to think of something here. If x is 0, tell me what you're getting. Let's see. Y equals a over 0 plus q. You can never divide by 0, right? You can never divide by 0. So we can therefore say, for grade 10 only, by the way, this is for grade 10 only. So we can say x is equal to 0. This is your asymptote, right? So remember, this is for grade 10 only. Okay, this is for grade 10 only. Okay, guys. Now, Let us then look at, okay, I'm done with the asymptotes. Now let us look at our graphs. I want to basically summarize our graphs, but before that, let me look at the axis of symmetry. Okay, I'm going to look at axis of symmetry. Now let's look at axis of symmetry. So let me begin with your standard cosine, I'm saying cosine, your standard hyperbola. Remember, your standard hyperbola is this one, y equals to 1 over x, right? 1 over x. This one, when you look at it, if you were to plot it, you will have x minus 3, minus 2, minus 1, 0, 1, 2, 3. Okay, 3. And then you have y. So you would have minus 1 over 3, minus 1 over 2, minus 1. Oops. This value, you cannot divide by 0. So it means at this point, you are in deep trouble. The graph does not exist. And then here it's 1, here it's positive half, and then here it's positive 1/3. Okay, now when we draw this graph, it'll be something like this. Let's see, it'll be minus 3, minus 2, minus 1, 0, 1, 2, 3. And then I dislike this graph. 1, 2, 3, 4. Okay, maybe let me make it this way. 1 and minus 1. I'm not saying I dislike it, as in like I don't like dealing with it. I like it. It's one of my favorite. But the drawing bores me. So now, remember, I said to you, the asymptote, we have the horizontal asymptote. Horizontal asymptote, remember, it's this one here. It is y equals q. What is q here? Q is 0. So this means y equals to 0. Why is y equal to 0? Here. So you see us drawing dots here. Okay. And then for grade 10, the vertical asymptote is always x equals 0, which is here. Alright, so it doesn't have X-intercept, right? So the graph, it looks something like this. Okay, the graph looks something like this. So if it were to shift up, okay, maybe let me write it like this here. If it were to shift up, let me call it 1 over x plus 1. If it were to shift up, your graph would be here, right? And then maybe you will have to find, it was going to be something like this. I'm not drawing it to scale, okay? It was going to be something like this. Remember, what you're seeing here is that there's broken lines. What they mean is that your graph will never touch this point, will never touch these broken lines, okay? They will never touch these broken lines. So remember, the effect of the positive is that graph goes up or goes down, okay? So let me erase it because I need to come back later. Okay, so now that we have covered, we are not really done, by the way, with the axis of symmetry. Now with the axis of symmetry, something that I want you to see is this one here. I want you to see that should I draw a line here, this line will divide these two graphs into two equal halves. Similarly, if I draw a line here, this line will divide the two graphs into, the two arms into two equal halves, right? So this one here, we can basically say axis of symmetry has two straight lines. One of the straight lines is y equals to negative x plus q. And then the other is y equals positive x. It's a straight line, can you see? But with a positive gradient, hence it's positive x plus q. Okay, this one here, the one that for this y equals to 1 over x, the the axis of symmetry would be y equals minus x because q is 0, and y equals to x again because q is 0. So for the axis of symmetry, you have two axes. For the hyperbola, you have two axes of symmetry. One with a positive gradient, this one here, and one with a negative gradient. Okay, so let me generalize this. For hyperbola, our axis of symmetry have the equation y equals to x plus q and y equals negative x plus q. Okay, guys? Great. Now, let's summarize how our graphs would look like before doing examples. So, it's just one summary. There's not a lot of summaries. It's just one summary. So, we're going to say, let me say when A is positive, and here when A is negative, and as usual, I'm going to have when Q is positive, and then when Q is negative. Okay, all right. So when A is positive, the graph lies between two arms, the first and the second quadrant, right? So when Q is positive, this line will shift up. Now your graph will look something like this and something like this. Remember, in grade 10, this line you always have an asymptote. Okay? Now, when Q is negative, let's look at it. You will have something like this and then something like this. Of course, this is x, this is y. Let me put it here as well, x, y. Do not forget, okay? Can you see that? Look at it. When Q is positive, it is shifted up. When Q is negative, it is shifted down. And indeed, it is between the first and the third quadrant. Okay? First and third. Now, let's look at when A is negative. When A is negative, the graph lies between the second and the fourth quadrant, right? So when Q is positive, let's try when Q is positive. When Q is positive, you have something like this. So our graph would look like this. This is when A is negative, right? And Q is positive. Now, sorry, let's look at when Q is negative and A, both A and Q are negative. The graph would shift down, right? And what did we say? We said it is in the second and fourth. Remember, the graph will never touch this point here. Okay, the graph will never touch this point here. Okay, guys. So this is your hyperbolas, your grade 10 hyperbolas. Okay, this is your grade 10 hyperbolas. Now, what's left of us now is to perhaps before we proceed, we need to look at domain and range. Very important aspect. Now, domain and range. Domain and range. Now, if you remember well, domain is the set of input values which looks at x values. So for grade 10, your domain, you will always say, look at our function. It goes for all values of x except when x is 0. What is this? Except for the vertical asymptote. Alright? It goes for all x values except for when x is equal to 0. This is for grade 10 only. Okay? So, but in grade 11 and 12, guys, this thing will change. Okay? So, for grade 10, you need to know this. X is an element of a real number, but x is not equal to 0. Remember, when we say real numbers, we mean you can take the positives and the negatives, the decimals, whether they are positive or negative. Alright? It will allow any value, but not 0. Okay? Now, the range, if you remember very well, we looked at the vertical asymptote. Now, let's look at the range. Look at the range. It can allow any y value, but that y value must not be q. Remember, the graph will never touch q. So it can allow any y value, but not q. Okay? So what is our answer? Y is an element of real numbers, but y is not equal to q. Okay? Now this treasure. Okay, now this treasure, you will also use it in grade 11 and 12. Okay, guys? Great stuff. Now, let us now try examples. Try examples and try to have fun with them. Okay? All right. Now, examples, we'll try number 1. Number 1 says, given y equals 2 over x plus 2, 1.1, calculate the x and y-intercept. (1.2) Find the asymptote. Number 1.3, sketch the graph. (1.4) Find the domain and range. (1.5) Determine the axis of symmetry. Remember, axis of symmetry divides the graph into 2 equal halves. Okay, now let's look at our answers. I'll try a different color. So for our solutions, 1.1 says calculate the x and y intercept. So for x-intercept, remember what it means is that where there's x, you put 0. Alright, where there's x, for x-intercept, where there's y, you put 0. Alright, so 0 equals 2 over x plus 2, meaning minus 2 equals 2 over x. Right? Now what do we have? We have negative 2x equals 2. Therefore, x equals negative 1. Alright? So you can leave it like this because the question said determine the x and y-intercept. This is at x equals 1. Or in coordinate form, you can say this is minus 1 and 0. Right? It's okay. Now, let's look at the y-intercept. So with the y-intercept, where there's x, we put 0. So y equals 2 over 0 plus 2. It does not exist. Can you see that? So we have no y-intercept. The reason I'm saying we have no y-intercept, guys, is because we're dividing by 0. That is not impossible. Okay, it should never be. Okay, great. Now 1.3 sketch. 1.2, find the asymptote. Okay, find the asymptote. 1.2, find the asymptote. Remember, y equals 2 over x plus 2. Now your asymptote, vertical asymptote, just to remind you, it's always x equals 0. Okay, you don't have to write vertical asymptote. Okay, you don't have to write vertical asymptote all the time, so you can just write x equals 0. That's okay. Now horizontal asymptote, this is me trying to remind you. Horizontal asymptote, this is this one here, so it's a y value, so y equals q, right? So check this one, a equals 2, so this means the graph must be like this between the first and the third quadrant, and then q is 2. This means it has shifted up. So now what is our horizontal asymptote? It is y equal to 2. Okay, it is y equal to 2, right? It is y equal to 2. Now let's head to number 3. 1.3 says sketch. So I will say x minus 3 minus 2 minus 1 0 1 2 3. Now remember y. So if you remember well, y was 2 over x, so 2 over minus 3 plus 2. What is it? It is minus 4 over 3. It is minus 4 over 3 minus 2. This one looks like 0. 1. Okay, 2 over minus 2 plus 2. It's 1. Is it 1? Yes, it's 1. And then this one here, minus 2 is 0. Y is 0. And then, so did we get y-intercept of minus 1 and 0? Let me confirm. Oh yes, we did indeed. Okay, so here at 0, this graph does not exist at x equals 0. So y, what do we have? We have 2 plus 2 is 4, and then here we have 2 divided by 2 is 1, plus 2 is 3, 2 divided by 3 plus 2, so 2 over 3, 6, 8 over 2 divided by 3. Let me check. Oh, sorry, not 2 divided by 3. This, yeah. Oh, yeah. 2 divided by 3 plus 2 would be 8 over 3. Would be 8 over 3. Okay. So now our graph, let's see, would look something like this. First thing first, the graph has shifted up by 2 units. So let me try this one to be 1. And then this one here to be 2. So it has shifted up by 2 units, and then maybe this one here, call it 3. Yeah, the space is too big, so let me call this one 1 2 3, and then this one here, let me call it my 0. 1 2 3 1 2. Okay, 1 2 3, then 1 2, maybe 3 here. Okay, so this is y-axis, this is x-axis. So first thing first, first thing first, I appreciate that this point here, let me use a bigger font. Yeah, let me use a bigger font. Okay, right, the graph does not exist here, and it doesn't exist also at y, because we said y equals 2 over x plus 2. It also doesn't exist here, right? Our y-intercept was minus 1. Our y-intercept was minus 1 and 0. So let me not try to be fancy. Our graph looks something like this. Okay, if you follow these things, you plot them accordingly, you will be getting something like this. Okay, so this is how our graph looks like. Okay, all right, guys. So remember this, you can, to get these values, you can quickly use the table form on your calculator. Okay, you can quickly use the table form on your calculator and it'll return all the values that you need. Okay, it'll return all the values that you need. Okay, now let's find the domain. Let's find the domain and range. 1.4, let's find the domain and range. So the domain, we said x is an element of a real number, and because we are in grade 10, it can allow all x values, but it will never allow x equals 0. Can you see that? It will never allow x equals 0. So we'll say x is an element of a real number, but x is not equal to 0. For the range, it will allow all y values, but it will not allow the horizontal asymptote. This horizontal asymptote is your q value. So equals r, y is an element of r, but y is not equal to 2. Okay, that is your domain and range. Remember, this one is the domain, this one is your range. Okay, this one is your range. Okay, all right, guys. Now determine the axis of symmetry. Now the axis of symmetry 1.4, the axis of symmetry, we said we have the equations y equals x plus q and y equals negative x plus q. Our q value was 2. Without any waste of time, our axis of symmetry is y equals to x plus 2 and y equals negative x plus 2. So if you were to plot them, that would be y equals to x plus 2 would have the y-intercept, so they would be passing here. Let me use a different color. That would be passing, I don't know where exactly, but somewhere here and somewhere here. Can you guys see that? If you draw them to scale, they will be like that. So pardon me. Yeah, I know. Maybe I should try. Yeah, maybe let me try to make them proper. It looks like 2 and minus 2 can work, and then 2 and 2 can work. Is it? Yes. So it'll be something like this, because y-intercept is 2, so y equals to x plus 2. Yes, and then this one here as well. This one here as well. Right. So this would be your axis of symmetry. Do you guys see that? Now this is you answering your question, and you get all your full marks. Okay, now let's try number 2. Number 2, write down the equations when y equals a over x plus q. 2.1, the graph is this point is minus 2, and this one here is negative 2, and then this one here, oops, I don't know, and then 2.2, we have and then we have this point here is -1 and 2, and then this point here is 1. Okay, so let's see. I should have used a different color, but it's okay. So for our answers here, remember we have y equals a over x plus q. For this graph here, as you can see, the asymptote is where? The asymptote is at y equals -2. So we are sorted. We have y equals a over x minus 2. However, we also are given another point. This point will help us to find a. What is this point? This is the x-intercept, which is -2 and 0. So the point is -2 and 0. So where there's x, you put -2. Where there's y, you put 0. So x is, y is 0. And then x is -2. And then like that. So we have, let's see, we have 2 equals, or maybe let me not say, let me just take this one to the other side. A over 2 equals -2. What do we have? We have a equals -4. In case you get confused, it's similarly to multiplying by 2 over 1. Multiplying by 2 over 1, because these 2 will cancel these 2. Or simply it's 2 over 2. Okay? Simply it's 2 over 2. This is why our a is -4. Therefore, this graph, we can say it is, the equation is y equals -4 over x minus 2. Indeed, it makes sense that a is negative. Can you see that? When a is negative, we said it lies between, there. It lies between the second and the fourth quadrant. Okay, now let's try this one here. With this one here, we have y equals a over x plus q. We don't have any information about q, so we will have to tread carefully. Okay, we will have to use this point. Let me try to separate the pages. So let me try to separate it here. So this one, we said we have y equals a over x plus q. So what do we have? I suspect if we say we use this one, maybe we will get something. I do not know, guys. Maybe we will get something. I do not know. But let's try. This point here is 1 and 0. Right, so let's try 1 and 0. What happens at 1 and 0? At 1 and 0, when x is 1, y is 0. So let's see. 0 equals a over 1 plus q. Right? So what do we have? We have a equals -q. Can you guys see that? Alright. Now, what does it mean? It means now we can say y equals -q all over x plus q. But now we have another point. We will use another point. What is that point? That point is -1 and 2. Again, where there's x we put -1, where there's y we put 2. So 2 equals -q over -1 plus q, right? Remember -1. So what do we have? We have, let me go, I'm moving to the side here. I don't want to go to the next page, so let me just do everything here. So we will have 2 equals negative divided by negative is positive. So we have positive q plus q. What is this? This means 2 equals 2q. Therefore, q equals 1. So if q equals 1, remember here, q equals 1. We said a equals -q. This means a equals negative 1. Indeed, A is negative. Can you see that? So our results seem to be working. Therefore, we can say y equals negative 1 over x plus 1. Okay? This seems to be working. So guys, this is how we solve our parabola problems, and I hope this was enlightening for you. So until I see you the next time,